Natural logarithm. Now it is time to discuss this topic, natural logarithm. If you missed my introduction to natural logarithm, sorry for that, then I guess you need to watch part 1 of this series of videos, because I explained there carefully and extensively where the logarithm or natural logarithm is related to exponential function with a base e. Okay, natural logarithm. We can start with logarithm just to make a review. Logarithm, we know that it is the inverse of an exponential function, for example, a raised to x, and the inverse of that is y is equal to logarithm of x with the base a. So for example, y is equal to 10 raised to x. Then inverse of that is logarithm of x. I've shown you before the graph of this. We can see again later. And the natural logarithm is that when our base is e, the irrational number e, that is a constant. E is a constant, the same as a is a constant. So this is a constant. Okay? And the inverse of this is y is equal to logarithm of of x with the base e. But instead of using logarithm, then we're going to use the natural logarithm. In your calculator it is ln, so the natural logarithm can be written ln instead x. So this one, the inverse of an exponential function with a base x, base e, is the inverse of that is y is equal to ln of x. Okay, with that in mind, then I will going to show you the graph of a function, an exponential function, as you can see here, that one, the blue one, have y is equal to 3.1 raised to x, and the inverse, the orange or the red, orange, logarithm of x with the base 3.1. They are what's this? They are inverse or mirror of each other, like what we did before. I did this. They are mirror of each other. Okay, I am going to remove that and then have that in mind so that you can understand even this one. As you can see here now, because it's a constant, I cannot move the lines now. The green one is, the green one is y is equal to e raised to x. It has a base of e. Okay, that's constant. E is constant. And instead of using logarithm, we have ln, natural logarithm of x. And as you can see the graph, they are also as a mirror of each other. They are inverses of each other. Okay. So, in logarithm, I will always go back to logarithm first. In logarithms, we have this y is equal to a raised to x if and only if x is equal to logarithm of y with the base a. That means x is equal to logarithm of a raised to x with the base a. This was a very good property that you need to remember. in natural logarithm, ln, I'm going to use ln now, we have y is equal to e raised to x. I'm going to follow the definition there, if and only if x is equal to logarithm of y with the base e. That means instead of using that, then I will use logarithm of e raised to x with the base e. That means. But instead of using logarithm, then we need to use natural logarithm. That means ln of y. That means x is equal to, I'm sorry for that, natural logarithm of e raised to x, because we have our y is e raised to x. And this is also a very good property of natural logarithm. It is almost similar with the logarithmic there. Okay. And then we also learned that we have x is equal to a raised to logarithm of x with the base a. That is also x, the property of logarithm. If we transform that in natural logarithm, then we have x is equal to e raised to ln of x. Okay? And then we learned also in logarithm of a with the base a is equal to 1, because the exponent there is 1. And then logarithm of 1, it doesn't matter what is the base, it is always equal to 0. So if we use natural logarithm now, this is ln of e is equal to 1, because of the exponent is 1. And then ln of 1 is also equal to 0, because e raised to 0 is 1. Okay, so it is the same, almost similar. And in logarithm, we learned also different laws of logarithm, like this one. Logarithm of a plus logarithm of b is equal to logarithm of ab. If we transform that is in ln, so we have ln of a added by ln of b, that is equal to ln of ab. Ln of a subtracted by ln of b, that is ln of a divided by b. And if we have ln of a raised to n, that is a, not x, is equal to n ln of a. So you don't need to remember this, just remember this, it's enough. And then if you deal with the exponential function with the base e, then use natural logarithm instead. Okay. In my next video, we will be discussing some examples that deals with natural logarithm. See you there. Thank you for watching.